Now dear student, we are going to discuss question number 4.26, and in this question it is given to you a solenoid. Listen carefully. Actually this is a good question. Clear? In this question it is given a solenoid having length 60 centimeter. So I am writing here length of a solenoid 60 centimeter. Okay, and a radius of 4 centimeter. Okay, radius is also given. It's good. 4 centimeter. Fine. Has 3 layers of windings of 300 turns each. Okay, fine. So do you know, whenever a term solenoid comes in our mind, always keep in mind here you have to find number of turns per unit length. Clear? So can we calculate here number of turns per unit length? Number of turns divided by per unit length. But it is also given here we have 3 layers. Clear? So we can say here we have 3 layers, and in one layer we have number of turns, that is 300. Clear? And we have to divide with length. Length of this solenoid is given 0.60. Clear? So from here you can say, we can write like this: 900 divided by 6 by 10. Clear? So we can say this is 2, this one is 3. So from here we can say 10 into 300 divided by 2. So we can say we have number of turns per unit length, this is 1500. Clear? So small n value we can take 1500. Next, it is also given a 2 centimeter long wire of mass 2.5 gram lies inside a solenoid. This is very important. Clear? So we have a solenoid, and inside solenoid, let's suppose like this, we have a solenoid, and inside this solenoid, let's suppose we are placing a very small wire, and this small wire is now connected with the external battery. Clear? So it is given in a question. Clear? So definitely it is given the magnetic field, this is perpendicular to this wire. Okay, fine. The wire is connected through 2 leads parallel to axis of the solenoid. This is clear. External battery which supplies a current of 6 ampere. Okay, in the wire. Clear? It means current is also given. This value we have 6 ampere. Fine. Clear? So what value of current in the windings of a solenoid can support weight of a wire? Clear? So now listen carefully. What value of current in a winding of a solenoid can support the weight of a wire? Now listen. So actually, now you can see whatever number one current is flowing in a wire. Clear? So definitely we can see whenever a current carrying wire is placed in a magnetic field, it will feel a force. Yes or no? So we know that one is feel a force. Clear? And that value we can see given by B. Let's suppose here we have BIL. So let's suppose we can say this is Bill. Clear to everyone? So now we can say let's suppose we are taking that value, that is L dash. Clear? Because this L dash is given to you 2 centimeter long wire. Clear to everyone? So here we have L dash, this is equal to 2.0 centimeter. Clear? 2.0 centimeter. Clear? So now we can say value of magnetic field. So first we can calculate value of magnetic field. This one is mu naught and I. Clear? So value of mu naught, this is given to you 4 pi into 10 to the power minus 7 into number of turns per unit length. This is 1500. Clear? And current that is flowing in a solenoid. So it is given to you no. Clear? So we can see it is not given. So let's suppose I am assuming this is I. Clear? Now we can say we can put this magnetic field in this expression. So from here always keep in mind here we will put I dash, because this is a current that is flowing in a conductor that is placed inside a solenoid and that is connected with the battery. Clear? So value of B we can say 4 pi into 10 to the power minus 7 multiply 1500. Clear? And we have I. Clear? Now it is multiplied with, now what is current actually carrying? This is 6 ampere. I can say 6, and L dash is given to 2 centimeters, so 2 into 10 to the power minus 2. Clear? Now this is a force that is acting on that conducting wire, and it is also given that which is support. Actually it is given here in this question that winding of solenoid can support the weight of a wire. It means definitely we can say this force that is acting, this force can support, I can say mg. Yes or no? So I can write actually like this. We can say from here you can write like this. This is actually F. F should be equal to mg, and this should be equal to 4 pi into 10 to the power minus 7 into 1500 I into 12 into 10 to the power minus 2. Clear? So now we can say, we know what is mass. Mass is given to you. This value we have mass. Where is the mass? 2.5 gram. Clear? So I can say 2.5 into 10 to the power minus 2 multiplied with 10. Clear? I can say 4 pi into 15 into 10 to the power minus 5 into I into 12 into 10 to the power minus 2. We can say this one and this one cancelled out. Clear? So from here, can we calculate value of I? Yes or no? So we can easily calculate this value, and this value will come out to be 108.3 ampere approximate, you can say. Clear? So now we can say like this, we can calculate value of a current that is flowing in a winding. Clear? So that it can balance that conducting wire. Clear? So I am again concluding this question. In this question, actually one solenoid is given to you. We are placing a conductor inside a solenoid. Clear? So, and we are actually also flowing a current in that conductor. So what will happen? Definitely whenever a current carrying conductor placed in a magnetic field, the magnetic field is produced by a solenoid. Clear? So at that time it will feel a force, and that force is the bill. Clear? Clear? Now that force is actually balanced by the self weight of that rod. So we can say that is equal to mg, and but for that bill we can say the magnetic field we can calculate by using solenoid. Clear? So value of B we can calculate from that side, and we can finally get value of I. Clear? So this is all about this question.